Today we will talk about time of flight mass spectrometry. But before discussing time of flight mass spectrometry in detail, we must know what is mass spectrometry. So, mass spectrometry is a powerful analytical technique, and this instrument, mass spectrometer, it is the most important and useful instrument for accurate determination of the relative atomic mass of an element based on the abundance and mass of each of its isotopes. Moreover, it is also used to find the relative molecular masses of the molecules. So, what is the principle behind mass spectrometer? Basically, as a substance passes through the mass spectrometer, a spectrum is produced of mass to charge ratio against the abundance. So, what happens? The spectrum can be used to find the relative isotopic mass. It can be used to find a relative isotopic abundance or the molecular mass or the structure of compound. And the peaks that we get in the spectrum, those peaks, basically the peak with the highest mass, you must know that that peak is the molecular ion peak, and it is sometimes represented like this, M positive. And the peak which has the largest abundance, or which is the tallest peak, that is called the base peak. So there are several types of mass spectrometer, but all of them, they are based on an ionized sample being accelerated through the mass spectrum and being separated based on the ratio of their charge to mass. So now let's talk about time of flight mass spectrometer in detail. So what is time of flight mass spectrometer? This is a common form of mass spectrometer where all the particles of the sample to be analyzed are ionized to form plus ions, like the positive ions. So these positive ions are then accelerated to the high speeds, deflected through the spectrometer, and then they arrive at the detector. And as they hit the detector, the mass spectrum graph is obtained, and the whole of the apparatus is kept under the vacuum to prevent any ions that are produced from colliding with the molecules in the air. Look at this. Let's discuss the stages that are in mass time flight mass spectrometer. They are here in detail. So there are 4 stages in time of flight mass spectrometer. These stages are ionization, acceleration, ion drift, and detection. So what happens in the stage number 1, which is ionization? You can simply see this is the ionization stage. In this picture, you can see sample is injected. They are being ionized over here. So sample are firstly ionized, then they are accelerated in this stage at the stage 2, and then at the stage 3, which is the ion drift, and you can see over here, they are separated on the basis of their, masses. So heaviest and light ions, they are separated, and in the detector we can detect them. Let's discuss them in detail now. So the first stage is ionization stage. There are 2 key ways in which the sample could be ionized. What are those 2 key ways? They are electron impact or electron ionization, and the electron spray ionization. So there are 2 key stages in this ionization. Let's discuss first, like how can we do the ionization using electron impact ionization. So basically, this is the method of ionization which is used for elements or substances which have a lower molecular mass. Basically, what happens in this technique, the sample is vaporized and it is bombarded with the high energy electrons, and these high energy electrons, they are fired from an electron gun, and the electron gun is a very hot wire filament which emits the electrons as the current runs through it. So as the sample is bombarded by these electrons, an electron is knocked off each particle and it forms a positive ion. You can simply see this. This is any element X. And when it is bombarded by the electrons, then electrons are knocked off from this element, forming a positive ion. So you can see uh, it is X positive and an electron is knocked out from this particle. So the positive ions which have been formed, they are called molecular ions, M positive or M positive ions, as we have discussed before. So these are then attracted towards negatively charged plate because you can see that they are positive in nature. So that is why they are attracted towards negatively charged plate. So this accelerates them through the mass spectrometer, and the molecular ion, it can be broken down further or it can be fragmented, and the fragments are also accelerated by the sample through the sample and hit the detector. So it causes different peaks to show on the mass spectrum, which is then afterwards produced. So this is about the electron impact ionization. Now let's talk about the electron spray ionization. What is electron spray ionization? Basically, this method is used for the substances which have a high molecular mass. So unlike with like electron impact ionization, fragmentation is unlikely to happen in this procedure, and this is therefore often called as soft ionization technique. Why? Because unlike the electron impact ionization, fragmentation is unlikely to happen. So that is why this is often called as a soft ionization technique. And for this method, basically, the sample is dissolved in a volatile solvent, and the solvent is then injected into the mass spectrometer using a hypodermic needle. And that hypodermic needle basically that produces a fine mist or an aerosol, and the needle is attracted by a high voltage supply. So as the sample is injected, and the particles are ionized by gaining a proton from the solvent. So this is how you can simply see the element or the particle, it gains the protons and it becomes like X positive, XH positive. So the solvent evaporates afterwards, and the XH positive ions, these are the positive ions, so they are basically attracted towards the negatively charged plate, and this accelerates them through the mass spectrometer. So this is the principle behind the electron spray ionization. Let's see it with the help of the diagram. You can simply see the diagram in here. This is the sample in the volatile solvent is injected from here. It makes the aerosol or the fine mist of highly charged droplets. Basically, this is the ionization chamber, and it forms positively charged ions in the gaseous phase. And afterwards, after the positively charged ions are formed, they are attracted towards the negatively charged plate, and this accelerates them through the mass spectrometer. So this was about the electron spray ionization. This was the first stage, which is the stage one of the time of flight mass spectrometer, which is ionization. So what is the stage two? It is acceleration. So let's discuss what is acceleration. In the acceleration state, basically the positive ions that are formed, they are accelerated using an electric field, and like these positive ions can be formed from either ionization method that we have discussed above. They are accelerated using an electric field, and they are all accelerated to have the same kinetic energy. This is important for you to remember when completing the calculations, when you are completing the calculations. So you need to remember this, that they are accelerated using an electric field and they all have same kinetic energy. So since all the positive ions, they have same kinetic energy, that is why their velocity will depend on their masses. This is the important part that you need to remember. And lighter ions will move faster and heavier ions will move slower. Let's talk about the third stage, which is the ion drift. What happens in this stage? So basically, the positive ions will pass through a hole in the negatively charged plate and they move into the flight tube. So this is where the name time of flight comes from. Like at this stage, the stage of the ion drift. In this stage, the positive ions will pass through a hole in a negatively charged plate and move into the flight tube. That is why this is where we call the name time of flight. So it comes from here. So the time of flight of each positive ion in this tube depends upon their velocity. Again, this is important to remember when completing the calculations. So I have highlighted the important points over here on the board. So it is important for you. Okay, let's talk about the stage number 4. Just the last stage is detection. In this stage, what happens? So once they have passed through the mass spectrometer, then the positive ions, they will hit a negatively charged detector plate, and as they hit this electric plate, they again get it. We can say they again gain an electron, and this gaining of an electron discharges the ion, and it basically causes a current to be produced. So the size of the current is proportional to the abundance of those ions hitting the plate and gaining the electron. And afterwards, simply the detector plate is connected to the computer, which will show us the mass spectrum which is produced. So this is about the fourth stage, which is the detection. You can see over here in below, I have written over here key equations that could be helpful for your exam dealing with the questions of time of flight mass spectrometry. So it is Ke equals half mv square. What is Ke in here? It is the kinetic energy of the particles. M is basically the mass of particles and V is the velocity. So kinetic energy equals half mv square. And velocity of the particles, it is equals to, when I will change this equation and I need to find the velocity. So velocity equals under root 2 ke divided by m. It is simple. Simply this 2 will go over here and it will be divided by this m. And in order to remove this square, I will place under root above this term. So that is why I get this value v equals under root 2 ke over m. I can also write the expression like this way. T equals d under root m over 2 ke. How this is so? Because I know that t is equal to d over v. That is why I will put the value of d over here. The value of v over here. So you can simply see what is t in here. It is the time of flight of the particles, and d is basically the length of the flight tube. So from where this expression arrives, it arrives from like t equals d over v. So I have simply placed the value of 1 over v over here. So I've inverted it in order to make it 1 over v. So it is under root m over 2 ke. So for your ease, I have written over here the full form of the abbreviation. You can simply see it. K equals kinetic energy, m equals mass, v is the velocity of particles, t is the time of flight of the particles, and d is basically the length of flight tube. So I have written over here the units of these as well over here. And for exam point of view, what you need to remember regarding the mass spectrometer is that all the particles in the mass spectrometer, they are accelerated to the same kinetic energy. Don't forget this thing for your question point of view. And the time of flight is proportional to the square root of the mass of the ions. You can simply see time of flight is proportional to the square root of the mass of ions, showing that the lighter the ion, the faster it will pass through and the quicker it will hit the detector. So it is an important point that you must know about the like from your exam point of view. And the heavier ion, what about the heavier ion? About the heavier ion is that the slower it will travel and the longer it will take to hit the detector. So this was all about the time of flight mass spectrometer. Let's practice the question regarding the time of flight mass spectrometry. This is a question over here on the board. This question is about the elements from the 7 block and P block of the periodic table. A sample of magnesium is analyzed by the mass spectrometry. The mass spectrum is below. So this is the mass spectrum. This is mass charge ratio. This is the relative abundance. Okay, so this is magnesium atom. So here it is the isotope 24, 25, 26 with the relative abundance. For 24, it is 78.99. For 25, it is 10%. For 26, it is 11.01%. So what is the question? The species causing the peaks in the mass spectrum are +1 ions of magnesium. Complete the table to show the number of protons, neutrons, and electrons in each +1 ion of magnesium. So what we need to do is that we need to complete this table. Simply we can see magnesium atom, if its atomic number is obviously it is 12. So here are 3 isotopes of magnesium with atomic mass 24, 25, and 26. So atomic number, it refers to as the number of protons or number of electrons. So here there are 12 protons and here should be 12 electrons, but you need to remember the question. Look at this question. We need to figure out the number of protons, neutrons, and electrons in each +1 ion of magnesium. So if it is +1, so 12 minus 1, it is 11. So we need to write 11 over here because it is for Mg positive ion. Mg +1 in the case of ion, 1 electron is removed. So we need to write 11 over here. And in order to find out the number of neutrons, so if we need to find the number of neutrons, it is simple. Mass number minus number of protons. So mass number, if it is 24, so 24 minus number of protons 12 equals 12. So here are 12 neutrons. Let's if it is the mass number is 25, so number of protons will be same because atomic number is 12, so it will be 12. How can we find neutrons? Mass number minus the number of protons, so mass number is 25 minus 12, so it is 13. So 13 over here. And how many electrons? Remember that we are dealing with magnesium +1 ion, +1 ion of magnesium. So if it would be a magnesium atom, in that case it would have 12 electrons, but it is Mg +1, so 1 electron is removed from magnesium. So that is why it would be 11. And in the case when we have got the 26 atomic mass or mass number, then in that case the number of protons would be 12 because 12 is the atomic number of magnesium. Number of neutrons would be 26, mass number minus the number of protons. So number of protons in here, they are 12. 26 minus 12, so here we have got 14. And for the same plus one ion of magnesium, the number of electrons will be 11. So what mistake some students do in such kind of question is that, like some candidates, they completed the table for the atoms. So what mistakes students do in such kinds of questions is that they complete this table for atoms rather than plus one ions with 12 rather than 11 electrons. So you need to be careful when like dealing with such kind of the question. Read the statement carefully in order to fill the number of electrons if they are asking about the neutral atom or if they are asking about an ion. Let's see the next question. Calculate the relative atomic mass of magnesium in the sample. Give your answer to 2 decimal places. Okay, we need to find out the relative atomic mass. How can we find the relative atomic mass? It is simple. Just multiply the mass with the relative abundance. So for magnesium 24, it is 78.9. I will multiply it, then I will add it up with the other isotope, which is 25, and I will times it by 10. And then I will add this with 26 times 11.01, and I will divide it whole by the 100. I will simply get my answer, the relative atomic mass of magnesium. So let's do it. So it is 24 times 78.9. I will add 25 and the isotope with mass 25 having the relative abundance 10.00. So I have times it, and simply I will add now the third isotopic mass with its relative abundance, which is 26 times 11.01, and it is all divided by 100. I will simply get my relative atomic mass, and that is 24.32. To the 2 decimal points, I've got my answer, 24.32. This is the relative atomic mass. Okay, the other question is that the copper used to make a batch of the coins and is analyzed by mass spectrometry. The mass spectrum is shown below. So this is the mass spectrum. Okay, calculate the relative atomic mass of copper, which is used to make coins. Give your answer to 2 decimal places. It is as simple. We will see copper 63 have the relative abundance 69.17. Copper 65 having the relative abundance 30.83. I will multiply the mass of one isotope with its relative abundance. I will add up it with the mass of other isotopes times with its relative abundance, with divided by 100. So let's do it. It's 63 times 69.17. I will add it up. with the other isotopic mass 65 with its relative abundance times 30.83 divided by 100. So what is the answer? My answer is 63.62 in two decimal places. I have written over here my answer. 0.62. Okay, this is the relative atomic mass of copper, which is used to make coin.